Hi everybody, I'm Joe for Amazon Web Services Training. In this video, I will be introducing you to the AWS well-architected framework. So as you all might know, as part of the AWS Cloud Practitioner exam, architecting is one of the component, and also for the Solution Architect course, this stands as a basic module. So, the AWS well-architected framework has been developed to help cloud architects build a very secure, high-performing, resilient, and efficient infrastructure for their applications. Now, they have basically defined 5 pillars based on which the framework provides a consistent approach for customers and partners to evaluate the architecture and also implement the designs that will scale over time. The framework basically includes strategies to help us compare the workloads against some of the best practices and also obtain guidance to produce stable and efficient system. Now, the page as such is well documented. So for details, you can refer to aws.amazon.com/architecture/well-architected. But in this module, let's go through one by one the well-architected framework which has been developed. Um, Now, this particular framework has been developed by AWS through reviewing thousands of customers' architecture on AWS. Okay, and it is designed to help us build the more secure, performing, and as I said, resilient and efficient infrastructure. It also provides a more consistent approach, which helps in evaluating the architecture and implementing the existing design patterns. Now, as you can see in the slide, the framework is designed to help you build and deploy faster, which means we stop guessing at capacity that is needed and take advantage of automation opportunity. And second is the lower or mitigate risk, which means that we understand where your risks are and address them before going live. Yeah. And about making an informed decision, it is more about determining how architectural decisions might impact performance and ability or availability of the application. It also talks about learning AWS best practices, which means assessing additional guidance through training or through white papers. Now, all the materials which are discussed in this training is available in the URL which I just mentioned before, including detailed white papers and also link to the training offerings. Okay. Now, in this slide, as such, what we are talking about is the framework is divided into 5 areas of focus, and it is referred to as 5 pillars of the well-architected framework, which includes operational excellence, security, reliability, performance efficiency, and cost optimization. So let's take a deeper look at each of these pillars and see what it actually talks about. So first one is the operational excellence. Now, the operational excellence pillar includes the ability to run and monitor systems to deliver business value and to continually improve supporting process and procedures. Now, let's take a look at some of the design principles which is mentioned here. So, perform operation as code. Now here, it talks more about treating your entire workload, including infrastructure, the same as you would actually treat your application code. So use scripting and automation to trigger actions in response to events. Now this will help you limit human error and enable consistent responses to the events. Okay. And then is about annotate documentation. which most often documentation is created by hand and doesn't automatically keep up with the pace of changes. So seek to automating the documentation update process to align with each change in the environment. Okay, and also you can use annotation as an input to your operations code. Now the third point about make frequent, small and reversible changes. So this is more about the design workloads to allow components to be updated regularly. Make changes in a small incremental fashion that can be reversed if there is a failure without affecting customers when possible. That's the key here. Okay. Now about the fourth one, which is more about refine operations procedures frequently. So as you evolve your workload, evolve the procedures appropriately, there is there is a refinement of operation procedure which is required. So it talks more about evolution of your workload. The fifth is about anticipate failure. So this is more about the research potential sources of failure so that they can be removed or mitigated. Now test both failure scenarios and failure response procedures. And the last one, learn from all operational failures, is about driving improvements through lessons learned from all operational events and failures. Okay. So let's move on to the next pillar, which is the security pillar. This primarily includes the ability to protect information, system, and assets while delivering business value through risk assessments and mitigation strategy. Let's take a look at the design principles for security that's defined here. So the first one is implement a strong identity foundation. So here what it means is that we need to stick to the principles of least privilege and enforce separation of duties. Use the appropriate authorization for each interaction with the AWS resources. Centralize privilege management and reduce or even eliminate wherever possible the reliance on long-term credential. Okay. The second one on enable traceability, this talks about how we monitor, alert, and audit actions and changes to the environment in real time, integrate logs and metrics with systems to automatically respond and take action. So there are some tools which AWS provides, which we will see in the later slides. But then, yeah, this is more about monitoring and alerting and auditing capability. The third one on apply security at all layers. Rather than just focusing on protecting a single outer layer, apply a defense in-depth approach with other security controls. Now apply to all layers, for example, the edge network, VPC, that's the virtual private cloud subnet, load balancers, every instance operating system and application. The fourth one about automate security best practices. Now, we are well aware of automation, right? So we all talk about automation. And here, automation improves your ability to securely scale more rapidly and cost effectively. So create secure architectures, including the implementation of controls that are defined and managed as code. The fifth point on protect data in transit and at rest. So here primarily classify your data into sensitivity levels and use case mechanism, such as encryption and tokenization where appropriate. Reduce or eliminate direct human access to data to reduce risk of loss or modification. And the last, prepare for security events. This is about, institute an incident management process. I know everywhere we have this, but then run incident response simulation and use tools with automation to increase your speed for detection, investigation, and recovery. Moving on to pillar 3, the reliability pillar includes the ability to recover from infrastructure or service disruptions, dynamically acquire computing resources to meet the demand, and mitigate disruptions such as misconfiguration or transient network issues. Here again, let's take a look at the design principles for reliability. The test recovery procedures. Now, in an on-premise environment, testing is often conducted to prove the system's working in a particular scenario. Testing is not typically used to validate recovery strategies. In the cloud, you can test how your system fails and you can validate your recovery procedures. You can use automation to simulate different failures or to recreate scenarios that led to the failure before. Now, this exposes failure pathways that you can test and rectify before a real failure scenario. So this also reduces the risk of component failing that have not been tested before. Yeah. Now the second one about automatically recovering from failure. Now, by monitoring a system for key performance indicator, the KPIs, you can trigger automation when a threshold is breached. Now, this allows for automatic notification and tracking of failure, isn't it? And for automated recovery process that work around or repair the failure. So basically making use of more sophisticated automation, it's possible to anticipate and remediate the failures before they can actually occur. Scale horizontally to increase aggregate system availability. So this is more about replace one large resource with multiple small resources in order to reduce the impact of a single failure on overall system. So distribute requests from multiple or smaller resources to make sure that they don't have a common point of failure. It's basically a single point of failure is what is avoided here. Stop guessing capacity. So a common cause of failure in on-premise systems is the resource saturation, right? When the demand placed on the system exceeds the capacity of the system, even including the denial of service attacks, that becomes a serious problem. But in the cloud, you can monitor the demand and system utilization and automate the addition or removal of resources to maintain the optimal level to satisfy demands. Now, this also leads to cost effectiveness because you pay only for what you use. The last one is about manage change in automation. So this is changes to your infrastructure should be done using automation. Now the changes that needs to be done or managed are the changes to the automation configuration, and it should not be a human intervention. Now going to the next pillar, the performance efficiency pillar. So this basically includes the ability to use computing resources efficiently to use or to meet the system requirements and to maintain that efficiency as the demand changes or the technologies evolve. Now looking at the design principles for performance efficiency, the first one talks about democratize advanced technologies. So some of the complex technologies require expertise that is not evenly dispersed across technical community, right? For example, a NoSQL database, media transcoding, or machine learning. Now in the cloud, these technologies can become services that your team can consume while they actually focus on product development rather than the resource provisioning and management. The second point on go global in minutes, this is more about how easily you deploy your system in multiple regions around the world with just a few clicks. Now, this allows you to provide lower latency and also a better experience for your customer at a minimum cost. Now, we all talk about the serverless architectures, right? So for performance efficiency in the cloud, The serverless architectures remove the need for you to run and maintain servers to carry out traditional compute activities. For example, the storage services can act as static websites, thereby removing the need for web servers, and event services can actually host the code for you. This not only removes the operational burden of managing these servers, but also can lower the transactional cost because these managed services operate at cloud scale. And with cloud, about the fourth point, you can experiment more often. So, with virtual and automatable resources, you can quickly carry out comparative testing using different types of instances, storage, or configurations. The last one about mechanical sympathy. So, this is about use the technology approach that aligns best to what you are trying to achieve. For example, consider the data access patterns when selecting the database or storage approaches. Yeah. Um, the next one is about the last pillar, which is the cost optimization pillar, and it includes the ability to avoid or eliminate unneeded cost and suboptimal resources. Let's take a look at the design patterns for the same. So, adopt a consumption model. So basically, pay only for the computing resources that you consume and increase or decrease the usage depending on the business requirement, not by using elaborate forecasting, right? For example, the development and test environments are typically only used for 8 hours a day during the week. Now you can stop these resources when they are not in use for a potential saving of say 75%, which is 40 hours versus 168 hours. Um, then measuring the overall efficiency is about measuring the business output of the system and costs which are associated with delivering it. Now use this measure to understand the gains you make from increasing output and also reducing the cost. The third one on stop spending money on data center operations. So this is about AWS does a lot of heavy lifting of racking, stacking, and powering servers. So you can focus your customers and business projects rather than on the IT infrastructure. Now, about analyze and attribute expenditure, um, the cloud makes it easier for us to accurately identify the usage and cost of systems, right? So there are tools around it, which then allows attribution of IT cost to various business owners. Now, this helps measure the return on investment and gives the system owners an opportunity to optimize their resources and also reduce the cost. Now, about using managed services to reduce cost of ownership. This is very important and a very cost effective principle, right? So in the cloud, the managed services removes the operational burden of maintaining servers for tasks like sending email or managing the database. And because managed services operate at cloud scale, they can offer a lower cost per transaction or service. So with this, we have covered the 5 pillars and their design principles. Now, for more details, you can walk through the online resource which is provided. It has more details. So just visit this particular website and it will give you more details around the well-architected framework. The main AWS architecture site, it basically comprises of the videos of customers discussing their architectures. There are answer pages and guidance for setting up common application and solutions on AWS. There are case studies and security principles. Okay. So yeah, I hope it was a good session for you. We have discussed the goals and principles of the well-architected framework here. Um, Now, the next module is the reference architecture.